Hello students, welcome to my channel Mistri Sir Classes. I am your Mistri Sir. In these sessions, I am going to discuss very important topic radius of atom and relations between radius of atom and edge length. Now first of all, we will discuss in this video what is the importance of radius of atom and relations between radius of atom and edge length and why it is important for us. I want to telling you students, please listen to very carefully. In this topic is very important tools for calculate packing efficiency, empty space and as well as density, even density based numerical questions. That's why we will learn radius of atom and relations between radius and edge length. In this video gives clear idea about packing efficiency, empty space, density, even radius of atom. So concentrate and watch video. I am sure by the end of the video you will be just perfect and maximum of all the question solved solid state chemistry on the basis of radius of atom and relations between radius of atom and edge length. Let's begin the topic. First of all, radius of atom. Now what about radius of atom? So here it is definitions. It is defined as half of the distance between nearest neighboring atom in the crystal. Now I am drawing here a crystal. Now what about neighboring atom? That means touching atom. Touching atom we called as neighboring atom. So here it is atom we assume is spherical, that means this type of spherical shape. So here it is half of distance. Now half of distance, here it is radius. Here it is radius, that means radius it is represented by r. Now here it is, now distance of two spheres, half distance is called as d, distance. Two atoms, half of distance called as radius of atom. Now here it is expressed in the term of length of the edge. It is represented by a of unit cell of the crystal. That means now this distance, that means this atom to this atom, that means two nearest atoms, two distance of two nearest atom called as called as d, distance d. This is we known as a, that is edge length. So here it is, we will discuss to find out relations between radius of atom and edge length. Now as we know, a cubic unit cell, now there that means height, length and width, that means a b c which is equals to a which is equals to b and b which is equals to c, and alpha which is equals to beta which is equals to gamma which is equals to 90 degree. That means cell parameter and angle. So here it is, now I am draw a simple cubic cell. Now all two atom distance which is known as edge length, it is represented by a. So here it is very important note. So now we have to find out relations between radius and edge length for the different kind of unit cell. But here it is very important point, please note that students, if it have only find out to simple cubic cell, that means scc, while not applied bcc and fcc. Here it is very important, that means it is that we will discuss about only simple cubic cell, not only bcc and fcc. So here it is, first of all we will calculate the relations between radius of atom and edge length SCC, that means simple cubic cell. So first of all Now here it is, I can draw here a cubic cell. Now here it is, I am representing A, that means edge length. All are the edge length about distance of one to another atom, that means here to here to here, and here to here. Now here it is very simple, that means simple cubic. So no, we take no, two half of distance. Now two half of distance, that means A, which is equals to 2 r, that means r plus r, two half of distance called as edge length. Now here it is very important. Now a that means edge length, a edge edge length is 2r. But similarly r, which is equals to a by 2. Now here it is complete information, that means edge length is 2r, and radius, which is equals to a by 2, a by 2. Here it is relations between radius and radius of atom and edge length. So next one is BCC. Now here it is BCC, that's we called as body centered cubic. Now as we know, now here it is, I am writing here. So it is very important. Now see here, as we know, BCC has 2 atom per unit cell. Now here it is very important. Now here it is, the atom present in the center of cube touches a corner. Now look at here, look at here. Now this atomic parties make a triangle, but this triangle also touches this triangle. Now here it is, center of cube touches a corner atom, so that's the distance r 2r, distance of 2r. Now length of body diagonal in this cube 4r. How's it? Now look at here, students. Now here it is, here it is a sphere or atom. Here it is a sphere or atom. Now finally here it is a sphere or atom. Now as we know, half of distance, that is called as radius. So 1r. Now here to here, that means 2r, sorry r, and this to this point having r, and also here to here having r. So there are how many are there? That means 4. So here it is body diagonal, that means here it is body diagonal, and body diagonal in this cube having 4r. So where is it come? Now here it is, that means body diagonal equal to 4r. So let triangle BC by according to Pythagorean theorem. It is very important. Now first of all we will discuss now BCD, that means main. And why we take BCD first? Because as we know, BCC having a body centered, that means one atom inside of the body. So in this atom touches now this atom and this atom and also this atom. Now if you whether it is here or it is here. So I am taking here. So next one, applying the Pythagorean theorem. Now first of all, triangle BCD. Now what is the rule of Pythagorean theorem? The Pythagorean theorem is the square of hypotenuse of a right triangle is equal to sum of square of two other sides. Now here it is. Now look here. Now this is hypotenuse. That means this hypotenuse square, which is equals to now other two sides. That means CD square plus BC square. Now here it is applied the Pythagorean theorem. Now BD, that means hypotenuse, which is equals to two other sides. Okay. Now here it is another part of ACB, that means here it is touching atom. So we take this. Now here BC square, here BC, that means here it is hypotenuse. Now hypotenuse square, which is equals to other two sides, that means AC and AB square. Now here it is BC square, which is equals to AB square plus AC square. Now we consider as equation number 1, and here it is equation number 2. Now equation number 2 put on the equation number equation number 1. So we get BD square, which is equals to now CD and BC's value. BC's, that means this BC's value put on the AB square and AC square. Now here it is equation number 3. Now we put on the values. Now just we find now BD, that means 4R, and here it is, and here it is A, here it is A, and here it is also A, and here it is also A. How many A? That means 3 A, B, C. So now we move on. 4 R square, which is equals to A square plus B square plus A square plus A square plus A square, because all edge length is equal. So we extend the value. Now we get 16 R square, which is equals to now 1 2 3 R square. Okay. Now first of all A here stayed, but now we get this type of equations. Now finally we get A, which is equals to 16 by 3 R square. Now whenever remove the square, so we put so we apply half. So in these equations we get A, which is equals to 4 pi, because here it is cut on the root, 4 pi under root 3. Under root 3, now here it is very important, that means value of A, BCC, value of A, which is equals to 4 pi upon under root 3, 4 pi under root 3. And whenever we find R, now R is a state which is equals to, now here it is cross multiply. Now we finally we get R, which is equals to under root 3 upon 4a. It is very important, because we are calculating the radius of atom and relations between radius of atom and edge length. That means here it is A is edge length, that means edge length of BBC 4R upon under root 3, and radius of atom of BCC, which is equals to under root 3A upon 4. So finally we calculate the radius of atom and relations between radius of atom and edge length. So here it is, I am drawing here previously. Now FCC, now as we know FCC, here it is very important for phase. So now this is the phase. I am directly doing here. Now hypotenuse, which is according to Pythagorean theorem, hypotenuse which is equals to two other sides. Now look at here. Now 4 pi, if I put A, B and C, so AB square, which is equals to two other sides. Now two sides, that means here it is A and also here it is A, and this side is 4 pi, 4R. So we getting 2A square, which is equals to 16R square. Now A square, which is equals to 16 by 2R square. 16 by 2R square. If that case we forward, now A by A square, which is equals to 8R square. Now finally we get 2 under root 2R, or R which is equals to A by and 2 under root 2, that means finally we get 2 under root A upon upon 4. Now see students, now summary of relations between age length and radius of atom. Now this type of table we tabulated already. Now here it is system, second rank or unit cell, and third relations between radius and age length. Now radius we represented as r and age represented as a. Now just we calculate simple cubic cell, rank is 1, and what is the radius, that means a by 2, and what is the age length, that is a, which is equals to 2r. Now definitely that's multiply a, which is equals to 2r. So I am here did separately. Now next one is BCC. Here BCC, that's rank or unit cell is 2. Now R, which is equals to under root 3 upon 4. Now just before we calculated this value, and A, which is equals to, now here you see, now A stayed here, and that's multiply 4R under root 3. So FCC, that's a unit cell is 4, and R, which is equals to under root 2 by 4, and A, which is equals to, just see here, he stayed here, and 2 comes here, 2 comes here, that means that means denominator form. Okay, A, which is equals to 4R upon under root 2. Here it is very important. Now we use this calculated data. Now finally we will get packing efficiency, density, and many others questions and solutions. So here it is very important, students. Now lastly about 10 to 12 minutes we calculated this value. So finally if you remember this value, you save your 10 minutes. So it is very important for next topics. So next topic is packing efficiency. It's abbreviated from it PE. The percentage of total space which is occupied by the atoms or particles. Now formula is that volume occupied by atom, volume of unit cell or boxes or cube into 100. It is very important, students. Now many students they do not understand now what about cubes, and what is the sense of packing efficiency. It is very important. Now finally, packing efficiency, the constituent particles, atoms or ions are closely packed in crystal lattice. They can do so either by CCP or by HCP. In both cases, a number of free space or voids are left. The total space is not occupied. That means we draw now. We consider a container or a cube. Now here it is. Now I am doing a well arranged. Now see students. Now Now I am doing here a well arranged or definite pattern in crystal arranged in any kind of boxes or cube. Now so here it is. Now you see, now here it is a remaining space. These remaining space called as voids. This remaining space called as void. Now in this voids, how to left, how to minimize we learn packing efficiency. So now very simple, students. Now just think about that. Now what is the sense of packing efficiency? That means how to filling any kind of boxes. मतलब अगर आपके पास कोई बॉक्सेस है, तो उस बॉक्सेस है और उस बॉक्सेस के लिए आपको कुछ एटम्स प्रोवाइड कराई गई है, जस्ट लाइक अ लड्डू या कोई भी ऐसी एटम्स जो स्फेरिकल शेप में हो, बहुत से आपको दे दिया गया है, जैसे वो मार्बलस होते हैं जो बच्चे कंचा वगैरह खेलते हैं वो। और आपको बहुत अच्छी एक क्यूब और क्रिस्टल लाइक सब्सटेंसेस प्रोवाइड कराया गया और आपको बोला गया है कि आप इस बॉक्स को कितने अच्छे से पैकिंग कर सकते हैं या ऐसी कौन कौन सी चीज़ें हैं जिसकी पैकिंग बहुत अच्छी होती है। तो इस टॉपिक में स्पेशली हम इन्हीं चीज़ों के बारे में डिस्कस करेंगे कि अगर मेरे पास कोई कंटेनर है या बॉक्स है तो उस बॉक्स को कितने अच्छे से हम फिल कर सकते हैं। सो लेट्स द स्टार्ट। So let's the calculate the packing efficiency of simple cubic cell. So first of all we will discuss what is the requirement, students. Now previously I told you now why it is important, radius of atom and relations between radius of atom and edge length. Now see, now first applications on the radius of atom and atom and edge length. Now see, requirements. What is the requirement, student, for SCC? Now first edge length which is equals to A. Now volume of unit cell, that means volume of unit cell. What is the volume of unit cell, students? That means A. Volume means length, weight and height. So here it is A into A into A. Now finally we get A cube. If that case crystal different, like just that means a crystal cell parameter having different, that means A into B into C. So here it is put on A into B into C, but just we applied on this theory only for SCC, and SCC having the same kinds of parameters. So here it is A cube. Now relations between A and R, that means radius of atom and relations between edge length. Now finally A which is equals to 2 by R. Now just see, students, just I told you. Now what is the importance of radius of atom? Now here it is, and volume per one atom, that means here it is the formula of sphere, that means sphere. So here it is very important, that means one atom's sphere is uh, 4 4 by 3 pi r cube. And atom per unit cell, how much of per how many per unit cell for SSC? 1, that means rank of unit cell 1. So let's calculate the formula. Packing efficiency formula is volume occupied by atom, volume occupied by cube or boxes into 100. Now here put on this formula. So 1 into 1, that means rank of unit cell, rank of unit cell rank of unit cell, that means in which kind of cubic crystal, on the behalf of cubic crystal, here it is put on its unit cell. Now we calculate SCC. So SCC unit cell or rank of unit cell is 1. So 1 into per 1 atom, 4 by 3 pi r cube. And volume of cube, so volume is what? A cube, and A's value is that 2r into 100. So we put on the value. Now here 1 into 4 pi r cube upon A cube here, and this denominator 3 comes of final denominators into 100 into 100. 100. Now we put on here, which is equals to 1 into 4 pi r cube upon A. What is A? A, that means 2r. So we put here 2r 2r cube into 3 into 3 and final 100. So we simplified 4 into pi into r cube. So here it is 2 2 pi 2 2 into 2 into 2 into r cube into 3 into 100. So here it is very simple. Now 4 upon 8, 2 to the 4, 4 to the 8 into pi and r cancel, r cancel, 4 pi, 4 pi into 100. Now finally uh, pi by how much? Pi by how much? 8. Sorry, I am not writing here 3. Okay, 3. So 4 to the 8. So finally we get 6 into 100, and pi's value we will put here 3.14 upon 6 into 100. So here values come to the point which is equals to 0.5 into 5 into 100. Now finally how much? That is 52 point something, that means overall about 52%. So what is the empty space, students? Empty space, em, empty space is that empty space is that 100 minus 52 52 52%. How much, students? 48%. That means SCC cubic crystal, simple cubic crystal, remains the space 48%. It is very important, students. That means जो simple cubic cell होता है वो मैक्सिमम 52% ही फिल किया जा सकता है, जिससे 48% क्या होता है, उसमें स्पेस रिमेन होता है, जिसे वाइड्स कहते हैं। इसके बाद जस्ट वीडियो में जस्ट हम लोग वाइड्स के बारे में डिस्कस करेंगे। सो नेक्स्ट वन BCC। Now here it is packing efficiency of BCC. Now same just before I told you. Now requirements just edge length A, volume of unit cell A cube, volume of per unit cell 2, that means BCC having how many unit cell? 2, and volume per atom 4 by 3 pi cube, and relations between edge length, that means A, which is equals to 4 pi under root 3. Just before we calculated. How to calculate? As we know. So formula is that volume occupied atoms, volume occupied cube or boxes into 100. Sorry, students. Now here it is, we put on the value. Now similarly last SSC we put here 1, and here it is BCC. So BCC's rank is 2. BCC's rank is 2 into 1 atom, 1 atom's volumes. So put here value 4 by 3 r cube by a cube into 100. Now here it is very simple, 2 into 4 into pi and into r cubes. Now these 3 comes here. So 3 into 4 pi. Now where is the come? 4 r under root 3 under root 3. Now here it is A's value. Now A's value is 4 pi upon under root 3. So we put here, and nextly now we simplified here 2 into 4 into pi into r cube. Now this denominator comes up numerator. So here how many times? 3. So under root 3 into under root 3 into under root 3. 3, and here it is 3 into how many times? 4. 3 times. 4 into 4 into 4 and r cube. 8. HR cancel, HR cancel. 4 to the 8. Okay, here it is 2 pi into 2 pi into under root 3 into 16, sorry, upon 16 into 100. Now here it is 2, 2 divide, that means 2, how many times? That means 8 times. So pi under root 3 into 8 into 100. Now we put pi value, that means 3 into 1, 4 into into now value of under root 3, here it is 1.78, 78 upon 8 into 100. Now look at here students, now look at here 3.14 into 1.78, how much students? Sorry, 5 point something. So divide 8, how much? 0.69, 0.69, so approximate 69, approximate 69. So here it is some mistake value students. Now you will check here. So let's how many percent failed in BCC? 68%. So what is the remain? 100 minus 68, 68 empty space, empty space, yes, empty space, 68, that means 32. दैट मीन्स बीसीसी में आप जितने भी अच्छे से फिल करें 32% वाइड्स रिमेन्स रह ही जाते हैं. सो इट इज़ वेरी इंपॉर्टेंट. दैट मीन्स ये एससीसी से अच्छी अरेंजमेंट होती है बीसीसी की. इट इज़ वेरी इंपॉर्टेंट. Finally, we reach FCC. FCC. Now, similarly, requirements of edge length A, radius of edge length of A, that means 4r by under root 2, and volume of unit cell, A cube, volume of per unit cell 4, volume of per sphere, that means per atom 4 pi 4 by 3 into pi into r cube. So here it is very important students. Now look at here students. Now here it is formula. Now we put on the formula. Now what is the 4? 4 is rank of unit cell into one atom's volume of one atoms. So here it is we put now 4 pi under root 2. Under root 2, what is the value of a cubes. So we simplified. Now you can write here 4, how many 4 into 4 pi r cube, and this denominator under root 2 go on the numerator. So how many times? So here it is 3. So under root 2 into under root 2 into under root 2 upon how many times? 4, 3, 1, 2, 3, and what is that means these 3 comes here 3, and how many are there? Is r, there is r, not a pi, there is r, there is r. So finally what is the remains? That means pi under root 2 upon 2 into 3, that means pi by 3 under root 2. Now value of 3.14, and this value finally we get 4.242, and finally what we get 3.14 into 1.414. 1 point, that means value of 2 is 1.4. 1.414 upon 2 3 is 6. So here it is 70 0.74. Now we get the percentage 74 and empty space is 100 minus 74, which is equals to 26. That means FCC arrangement is others better than others. That means सबसे कम स्पेस FCC में ही होती है, मतलब सबसे अच्छी अरेंजमेंट किसकी होती है, SCC, BCC और FCC में FCC की. So students, you can draw your fair copy. Now summary of packing efficiency. Now about 35 minutes video, it is very important, and last summary. Now radius of atom and relations between radius of atom and edge length, and here it is packing efficiency. So it is only important, but how to calculate, how to come these values, now we are calculated one by one. So it is very important, and I think you all understood now what I am discussing here. It is very important, very important. About 30% solid state chemistry completed in this video. So let's see now. First of all, system, crystal system, rank of unit cell, and relations between radius of atom and edge length, and packing efficiency, voids or empty space, coordination number, voids or empty space. Now look at here, simple cubic cell rank, as we know, only one. Where is the situated? Where is the situated? Only corner. So A value is 2 R, and R value is A by 2. Yes, previously I taught you how to come this value. Now packing efficiency 52, and voids remains crystal space, remains space on the inside the crystal, that means 48, and coordination number is 6. Now what about coordinations number? Now we will discuss next video. And BCC unit cell, that means rank is 2, and where is the situated of atom? Corners and as well as body, Now what is the A? 4R by under root 3, and what is the packing efficiency? That is 68, better than SCC. And how much of space remains inside the crystal 32, and it is also better than SCC, and coordination number is 8. And FCC unit cell is 4. Where is the situated atom? Corner as well as faces, So age formula 4 pi upon under root 2, and radius formula is under root 2 into A upon 4. And how much of percentage of packing efficiency? That's 74, and packing efficiency is better than BCC and SCC. And similarly, now minimum space left inside the crystal. So here it is also better than both. And finally, over this video, finally we completed two important segment and applicable topic, because beginning the video I told you what is the important of radius of atom, and relations between edge length and radius of atom. So first applications of in this topic is the packing efficiency. Now you saw how to using this data I am calculating this value, and finally we get empty space, voids, coordinations number, and relation. So it is very important, students. You do your best, and if you like this video, please subscribe my channel, like, share button, and will press the bell icon button. And finally you will practice, and next video we will discuss some important questions on this basis of this video and topics. So um, here it is enough, and this video is going to too long. So finally I stop this video, and next video we will soon. Thank you.